Hello, my beautiful students. Hope you're all doing well, having a great time, and staying safe. In this lesson, we will try to talk about electromagnetic spectrum. So, we are still in chapter 15, section 2, and let's start. You have all seen light before. What you have seen is the visible light. Now, visible light or UV light or ultraviolet light are types of electromagnetic wave. Now, these two are not the only type. We have many different types of electromagnetic wave, including X-ray, radio waves, microwaves. And you have learned in the previous lesson what is electromagnetic wave. Electromagnetic wave, if you don't remember, let me remind you, is a wave that consists of electric and magnetic field that vibrates at a right angle to each other. Or you can say is a wave that can travel through empty space or matter that consists of changing electric and magnetic field perpendicular to each other, and of course perpendicular to the direction of the wave motion. Let's talk about the characteristics of electromagnetic wave. The first one, all electromagnetic wave travel at the same speed in the vacuum, which is 300,000 kilometers per second. Could this be possible? Yes. This is because of the relationship between the speed of a wave and the frequency. Basically, the speed of a wave equals the wavelength multiplied by the frequency. What is the frequency? Frequency is the number of waves that pass a fixed point in a unit of time. That's about frequency. Also, electromagnetic waves that have different wavelength can travel at the same speed if their frequency are different. Then we will have to talk about electromagnetic spectrum. What is electromagnetic spectrum? Electromagnetic spectrum are all of the frequencies or wavelength of electromagnetic radiation, or you can say the entire range of electromagnetic wavelength is called electromagnetic spectrum. Now, according to their wavelength, the electromagnetic spectrum is divided into different regions. Though you will have to know that there is no sharp division between one kind of the wave and the next, as you can see in the picture in front of you. The image that you are seeing right now is the electromagnetic spectrum that is arranged from the long to short wavelength, or from the low to high frequency. Let's talk about the first type, which is radio wave. You will have to know that radio wave covers a wide range of waves in the electromagnetic spectrum. Radio wave have some of the longest waves and also lowest frequencies of all electromagnetic waves. That's not all. Well, radio waves are any electromagnetic waves that have wavelength longer than 30 centimeters. In the process of broadcasting radio and television signals, radio waves are used. This slide is basically what we have said in the previous slide. The radio waves have the lowest frequencies and longest wavelength of all the electromagnetic wave. Kata radio wave لنا همو electromagnetic wave كان دريكشتين wavelength عنها ونزمترين frequency عنها وهروها لبرودكاستي راديو تلفزيون شبكارين را. broadcasting radio signals. Well, the radio station encodes sound information into radio wave by varying either the wave, amplitude, or their frequency. And changing amplitude or frequency is called modulation. I'm pretty sure you have heard about AM and FM. Well, AM radio station is amplitude modulation and FM radio stations is frequency modulation. Comparing the AM and FM radio waves. So the first difference between AM and FM radio waves are their wavelength. AM radio waves have longer wavelength than FM radio wave. Also, AM radio waves can bounce off the atmosphere and thus can travel further than FM radio waves. On the other hand, FM radio waves are less affected by electrical noise than AM radio waves are. So, music broadcast from FM stations sounds better than music broadcast from AM stations. Now, I'm pretty sure you know that television signals is also carried by radio waves, but television stations broadcast radio waves that have shorter wavelength and higher frequencies if you compare it with the broadcast by radio stations. And they both use amplitude modulation and frequency modulation. By both, I mean radio and television. So let's talk about the TV waves or television waves. TV stations use frequency modulated wave to carry sound and amplitude modulated waves to carry pictures. But sometimes waves carrying television signals are transmitted to artificial satellites orbiting Earth. And these waves are amplified and sent to the ground antennas, and then they travel through cables to our home. بس چی من کرد؟ بس هی تلفزیون سیگنال من کرد که چون رادیو ویف هلیان اگره بلام تیوی ستیشن برودکاست کن چونه کن چه جور رادیو ویف بکارن او رادیو ویفانی که short wavelength يعني هو high frequency يعني short wavelength and high frequency. طبعا بو برودكاست كردن يعني AM و FM بكارين ريت بهمان شوي راديو كان بلام TV station كان FM بكارين رين بو قواسنوي دنك و AM مش بكارين بو قواسنوي picture رسم. أي كنالي أسمانيان satellite ئەوەی کە لە ماڵەکانمانەیە هەموو ڕۆژە بەکاریانێنین چۆنی ئیشەکەن وەڵ تەلەڤیژن سیگناڵەکەمان هەیە ترانزمی دەکرێت بۆ ئارتیفیشیەل سەتەلایتێک ئەوەنی کە بە چوار دەوری ئێرثە ئەخولەنەوە مانگێکی دەستکرد لەوێەوە چی لێکرێت ئەمپلیفایەکرێ یعنی گەورە ئەکرێ و دەگەڕێنرێتەوە بۆ سەرزەوی ئەنێرێ بۆ ئەنتێناکان لەوێشەوە بۆ کێبڵەکان و ئەگاتە ماڵەکانی ئێمە. As you can see in front of you, how the signals, radio signals, are sent to the artificial satellites and then back to the ground, to the antennas, receivers, and then to our home. TV signals are transmitted to artificial satellite orbiting Earth. The waves then amplified and sent to the ground antennas, then travel through cables to TV in homes. Microwaves. Now, if we try to compare a microwave to the radio waves, we will see that microwave have shorter wavelength and higher frequency. than radio waves do. Microwaves have wavelength between 1 millimeter and 30 centimeter. And I'm pretty sure you have seen a microwave oven, and most of us have it at home. As you can see in the picture, the microwaves reflect off a metal fan and direct it into the cooking chamber. We are cooking a chicken in front of you. Of course, in the picture in front of you, the metal fan is the stirrer. What does the energy of a microwave do to the food? The energy of a microwave causes the water molecule inside the food to vibrate, to move back and forth. The vibration of the water molecule causes the temperature of the food to increase. This is how a microwave works. Now, microwaves can penetrate several centimeters into the food, so it can go deep into the food. If you look at the picture, you will see another part of the microwave, which is called magnetron. This magnetron produces microwaves by accelerating charged particles. So magnetron چیه؟ هلسه به دروست کردنی microwave by accelerating charged particles. You should also know that microwaves are used in radars. Radars is used to detect speed and location of an object, as you can see in front of you. We also have a radar gun. The radar gun is used to detect the speeds of the cars. How the radar gun works? Now that's a question we need to answer. So the radar gun sends out microwaves that reflects off the car and returns to the gun. So it reaches the car and goes back to the gun. The reflected waves are used to calculate the speed of the car. We should also say that a radar is used to watch the movement of airplanes, and also it helps ships to navigate at night. Infrared waves. This wave have shorter wavelength and higher frequencies than microwave if we compare it. The wavelength of infrared vary between 700 nanometer and 1 millimeter. Just so you know, nanometer equals 1 times 10 to the power negative 9. You could receive infrared waves from the sun. Let's say that you are in a very sunny day outside in front of the sun and you feel warm. What happens is the following. Your skin absorbs the infrared wave, striking your body from the sun. Then what happens is the following. The energy of the waves causes the particles in your body to vibrate more. And you feel an increase in temperature. Though we will have to say that the sun is not the only source of infrared waves. Everything around you gives off infrared waves, including buildings and basically everything. So what happens that the amount of infrared wave and objects give off depends on the object's temperature. If we compare a warm, hot object to a cool object, the warm object gives more infrared. Also, you cannot see infrared waves, but there's device that can be used to detect infrared waves. For example, we have infrared binoculars. How does this device work? It basically changes the infrared waves into light so you can see. Such binoculars can be used to watch animals at night. The picture that you are seeing right now is taken with a film that is sensitive to infrared waves. Moving on to the visible light. The visible light is very narrow range of wavelength and frequencies in electromagnetic spectrum, of course, that human can actually see. Visible light waves have short wavelength and high frequency if we compare it to the infrared wave. Also, visible light waves have wavelength between 400 nanometers and 700 nanometers. For us, the source of visible light is the sun. The visible light from the sun is the white light. White light is a visible light of all wavelengths combined, so it is composed of many different colors. Light from a lamp at your home, as fluorescent bulb in your school, all white light. Since visible light has different wavelength, humans see different wavelength of visible light as different colors. As you can see, we have red. Now red has the longest wavelength. The shortest one is a violet. And also we have the visible spectrum. The visible spectrum is the range of colors, the 7 color that you are seeing, or the 7 color of the rainbow. For example, red, orange, yellow, green, blue, indigo, and violet. So remember, the visible spectrum contains all the colors of a light, all the 7 colors. Ultraviolet is another type of electromagnetic wave that have basically a shorter wavelength and higher frequency than a visible light. And the wavelength of UV light or ultraviolet light waves vary between 16 nanometers and 400 nanometers. Ultraviolet light can affect you in a good way or in a bad way. Let's talk about the bad effect first. Ultraviolet light can cause sunburns, or it can actually cause cancer, skin cancer, wrinkles, and could damage your eyes. But also you can protect yourself by using sunscreen, wearing sunglasses, and also wearing hats, long-sleeved shirts, and long pants can protect you too. Now, this is also important even if the day was very cloudy, because ultraviolet light can travel through clouds too. We should also say that much of the ultraviolet light from the sun does not reach the Earth's surface, but you should still protect yourself. The good side effects or the good effect of ultraviolet is the following. We actually have ultraviolet lamps that is used to kill bacteria on foods and surgical tools. That's not all. Small amount of ultraviolet light are beneficial or good for your body. Our body makes vitamin D by using the ultraviolet light. Vitamin D is very important because it allows the intestine to absorb calcium. And you know how much calcium is important to the health of our body, especially to the strength of our bones and teeth. X-rays and gamma rays. X-rays and gamma rays have some of the shortest wavelength and highest frequencies of all electromagnetic waves. First, let's talk about X-rays. X-rays have a wavelength between 0.001 nanometer and 60 nanometer. They can pass through many materials. This characteristics makes X-ray very, very useful in medical fields. But too much exposure to X-rays also can be dangerous because it can damage or kill your living cell. A patient getting an X-ray may wear a special apron. This special apron is actually used to protect the part of your body that does not need X-ray exposure. These aprons are lined with lead because X-ray cannot pass through lead, as you know. Medical field is not the only field that we use X-ray in, because X-ray machines are also used as a security device in airports and other public buildings, as you can see in a picture in front of you. This machine allows security officers to see inside bags and other containers without opening the containers, since it actually can penetrate many materials. Gamma rays, on the other hand, have the wavelength shorter than 0.1 nanometer. They can also penetrate most material very easily. Gamma rays is used in medical field to treat cancers, some forms of cancers. Doctors focus the ray on a tumor inside the body to kill the cancer cell. This treatment often has good effects, but it also can have bad side effects because some healthy cells may also be killed. Gamma rays are used to kill bacteria, harmful bacteria on foods such as meat and fresh fruits. This ray does not harm the treated food because they do not stay in the food. So if we had a food that has been treated with a gamma ray, it is very safe for you to eat. So gamma ray بەکارێنرێ بۆ چارەسەرکردنی هەنە جۆری کانسەر، دایرەکتی تومەرەکە ئەکرێ و ئەبێتە هۆی کوشتنی ئەو خانانەی کە سەرەتانین لەناو لەشە. بەڵام ساید ئیفێکتێکی هەیە، ئەویش ئەوەیە تەنها ئەو سێڵانە ناکوژە کە تووشی کانسەر بوون، هێڵثی سێڵەکانیش ئەکوژێ. طبعا ئەمە bad side effectە. Also بەکارێنرێ بۆ کوشتنی بەکتریا، ئەو بەکتریانەی کە زیان بەخشن بۆ خواردن یان بۆ گۆشت. بەڵام ئەبێ ئەگاداری ئەوە بی ئەگەر خواردنێکمان هەبێت تریتمنتمان بۆ کردبێ بە گاما ڕێی، ئەو خواردنە خراپ نییە ئەگەر بیخۆی، بۆ لەبەری گاما ڕێی لەسەر خواردنە نامێنێتەوە. سو ئەتوانی بیخۆی، سەیفە بۆ ئەوەی بیخۆی. We reached the end of this lesson, so thank you for your time and stay safe. And your homework will be the chapter review in page 289. So good luck.